Welcome back to Reconstructing Gravity, chapter G16. Why is there gravity? We've been looking at how gravity works, at least on a planet like Earth. Now let's extend that a little bit and try to explore why gravity exists. In general, problems can have different classes of solutions. There's the trivial solutions that are obvious but usually irrelevant. Non-trivial solutions, and which are more complicated, obviously. And then there's the question of whether the solution you find is a unique solution and whether you can prove that that's true. In formal mechanics, from the infinity of possibilities, solutions are found that fit a set of constraints. Now, this sounds fancy, and I don't intend to be fancy, but it's just a good way to organize your thinking about problems. First, there's usually a global governing equation, something that's true everywhere. Then there are typically boundary conditions, and that might be a starting condition for a solution that involves time, or it might just actually literally be a boundary condition for things that are true around the edges or at certain places within the problem, that those conditions have to be met. And sometimes there's also constitutive equations, which have to do with the way the material you're working with behaves, something specific that also needs to be matched. In everything I've presented in this video series, the global governing equation is essentially the requirement for harmonic equilibrium of energy motion within all mass particles. This has been our primary guiding principle both in special relativity and in the gravity modeling. This harmonic equilibrium of energy motion within masses is what gave us length contraction and time dilation in special relativity. And in our look at gravity, the ball drop, it was this lack of harmonic return to a different point, which gave acceleration downwards to a dropped mass in a gravitational field. Then, when looking at non-falling masses in a gravitational field, we said that a pressure gradient must cause a strain gradient, which is required to balance the gamma gradient, which comes from a space velocity gradient. All of that so that the energy within each particle returns to its original position instead of falling, instead of dropping to a new position. Then we found that both the internal velocity of space and the internal pressure were nonlinear functions of the radial position inside the Earth. And as I showed in my last video, the velocity of space flows just such that it creates a gamma, which balances the strain, which is caused by the pressure that gravity creates. And this balance is all the way in from the surface of the Earth all the way to the center. Looking at the equations, once again, remember gamma is a function of V over C squared. And this is the equation for internal velocities that we presented before. So the velocity squared looks like this. And the internal pressure, which we've computed before, looks like this. And what I'm suggesting here is this is no accident. This is a solution. I'm suggesting that space has to flow at this velocity in order to maintain the equilibrium of all the particles of mass inside the planet, in order to counter the strain gradient caused by the pressure which gravity causes. In other words, if space did not flow at this particular rate, it would create a different gamma function and a different pressure function, and they wouldn't align in such a way that they cancel the effects in order to maintain the harmonic equilibrium of every mass particle in the planet. It's a solution to how to keep all the mass particles of the planet in harmonic equilibrium. According to our constructive model's physical interpretation of relativity and gravity, this is why and how mass tells space how to move, or in spacetime lingo, why and how mass tells spacetime how to curve. I think we've also gained a little insight into why Penrose said that the source of gravity is energy density plus the sum of the pressures. Yet pressure isn't always mentioned in talk about Einstein's general relativity. Let's look at the equations again. If your concern is primarily external, then pressure isn't in the equation for flow rate dt, which is important in our analysis. It's only when you go internally that you see the pressure pop up. So internally to the planet, that's where the source of gravity is. Externally, you can describe it without describing the pressure. Now we come to what I think is a very interesting question, the issue of the trivial solution. Why is there gravity at all? The trivial solution is easy. Velocity of space equals 0, flow rate dt equals 0, internal pressure equals 0, strain equals 0. Why doesn't this happen? Applying this trivial solution to a planet begs the question, why would there even be planets or stars if not for gravity pulling them together in the first place? Think about this. If space stopped flowing for just a few seconds, the pre-existing pressure would blow these masses apart. So maybe a better question is, how do planets, stars, and gravity co-evolve? How do they come into existence together? My guess is it has to do with the compression associated with random collisions. Small lumps of mass might form due to chemical bonding, maybe, and randomly these would collide with each other in space. We know that when material bodies collide, there's always a compressive force created. For bodies of any size at all, this surface compression also causes internal pressure. Here's a picture from one of my engineering books about the problem of contact between two bodies. And to the right, the solution, the curve to the right is sigma z, that's the pressure in the direction of contact. You can see it's a peak at the point of contact, and then as you go farther away from that contact, the pressure fades off, but notice it fades non-linearly. Every collision is a short-term event, but each collision does involve a finite amount of time as the contact force rises to some peak, then diminishes as the masses rebound and separate. Could each momentary collision event cause a microgravity event, causing a momentary flow of space towards the point of collision? Over time, this would lead to a slow gathering of mass particles in a cloud of masses. Each contact impact would set up a situation similar to what we see in planets with pressure gradient, a nonlinear pressure gradient, and space might, just for that moment, temporarily adapt to try to maintain the equilibrium of those mass particles, of every mass particle within these contacting bodies. And if it did, if there was a space flow, that flow would generate a weak, very weak gravitational field around the contacting bodies. As the masses gathered slowly together, the frequency of collisions would increase until near some central region, collisions would become an almost continuous series of events, causing an almost continual space flow field. And then eventually those collisions would become so close and so rapid that the contact would just remain permanent, and the stress gradient, strain gradient would be continuous. Could this process be the genesis of gravity in a planet or a star? Well, that's enough for today. We've got more to talk about. Expansion of the universe, dark space and flow, still some issues there. Possibly the uniqueness of the solution, and whatever else comes up. Thanks for watching. Please like and subscribe, and leave a comment. Share if you like. Outro today, JJ Kale, Closer to You. Catch you next time.
Closer to you. If I am a necklace dangling down your front, when you feel the time was right, I know just what you want. Wish I was a silk shirt draped around your back, rubbing next to your skin, trying to make contact. Closer, closer, closer to you. Closer, closer, closer to you.